So my talk will be a little bit, hopefully, less technical than previous talks. And like it was just mentioned, it's about thinking outside the box. My name is Vadim Uchitel. You can guess which picture is mine, or it could be both. I'm not going to tell you which company I'm working for, but again, you can guess by looking at my T-shirt. So what's outside the box? The idea of that comes from 9-dot puzzle, which first appeared in 1914. To solve the puzzle, you needed to connect all 9 dots with 4 straight lines without removing your pencil from the paper. If you think inside the box and try to connect lines like you see on the left, then you will notice that basically the problem does not have a solution. On the other hand, if you would think outside the box and move your pencil outside the box, then there are plenty of solutions. You can Google online, but there are like 5-10 solutions to this problem. So what I'm trying to explain with my presentation is don't get cornered into what you see in front of you and try to think a little bit outside of what's going on. So we would look at a simple engineering software example. So let's say you're a new DevOps engineer that's joining a company that's trying to move legacy monolith module to Kubernetes. The code that you see in front of you, company provides sales data for the entire US, as well as for the specific state. And goal of this code is to return state data that is part of the overall data. As you can see, there are 2 for loops, which means it's of and square complexity of this code. And it also means that whenever our analytics department needs to run that code, it can take our monolith down because of extra complexity that it takes. And so as a new DevOps engineer, your goal is to take it out, move it to Kubernetes, and take that pressure off the monolith. And I'm sure as a DevOps or SRE, you know what it means, because goal for most of us here is basically to remove pressure from monolith and horizontally scale our applications. So what would be the proposed step to solve this problem? First of all, you're going to migrate the code into a new repository. Then you're going to add a Docker file, obviously, build a CI/CD pipeline to add your container into the cluster. As a good DevOps engineer, obviously, you're going to add proper telemetry, tracing, and logging. And we had a great presentation today about how to do that with tracing and logging. You're going to also integrate changes into gateway and UI tools. And obviously, you're going to create a SRE runbook, because SRE that you have to think about those guys who are going to actually support your code in production. And obviously, success, right? But one thing which which you haven't paid attention to is that sales data for the entire US and data for the specific state is actually part of the data for the entire US, which means this function is not necessary. And that's what you often see in a legacy code. Because the way what is legacy code base, is often written by a student or intern or a developer who just started early in the career, because it's a startup, and then that code is getting maintained for many, many years. That developer has left the company. 5 years down the line, 10 years down the line, you will see the same code being rewritten in multiple languages, potentially moved to a new code base, and nobody knows what it does and why is it doing that. Again, because we continue to think inside the box, because this code was written, it has to be there, but it doesn't have to be there. So every time you are porting a legacy code base, first of questions that you need to ask, why am I doing that? And that brings up my next question. Are software engineers humans or econs? So where is econs term comes from? It actually comes from economics books. If you read any of economics books, you'll see that they're talking about econs where accounts are perfect, calculated, and objective, while humans are not imperfect. And if you, I'm sure most of you went through some sort of boot camp, university to get your computer science degree, and what you were taught how to write algorithms, how to build algorithms, how to do machine learning, how to build compilers and all sorts of things. But in schools, we don't teach people, is that algorithm really necessary? Why are you actually doing that algorithm? Your goal is typically to have a code, build a batch algorithm. So in my initial code base which I showed, there was O of n square complexity. As a good software engineer, you would see that problem. You could easily add a dictionary to it, and you would improve performance to O of n, to make it a linear performance. At the same time, you're not answering the question, is this code necessary? And most of us, when we are writing code, we don't think in terms of, are we solving the right problem? That comes from tunnel vision. So tunnel vision is looking at things from a very narrow perspective and basically ignoring some facts. And common example, as I just showed, solving the wrong problem. Solving the wrong problem happens all the time, but very often it happens when you migrate your legacy code base, ignoring some use cases, selecting complex solution, and so on. There are so many examples where you are fixated at the solution and ignoring the problems that you're trying to solve. So I'm going to give you a few hints how to avoid it. At the same time, it's up to you, really. First of all, there are no silver bullets from my presentation. I'm just going to show what the issues are, and it's up to you as a human, as you know yourself better than anybody else, is how to adjust to biases that I will be presenting in my presentation. So how to avoid, take small frequent breaks, that reduce stress and fatigue, and go for a walk, take a bike ride, whichever works for you. It's so specific to a specific person that I'm not gonna prescribe what's better for you, but at the same time, that's been proven to help to avoid tunnel vision. Next bullet point on my slide, stay in a bad mood. It's a little bit counterintuitive, and what I want to say about that line, I was doing a dry run a couple of weeks ago. My wife was listening, and she's like, oh, wow, now I understand why you're in a bad mood when you're writing the code. But the studies in human behavior actually do show that people in good mood are basically more receptive to bullshit, and they believe in their own code, which is not good. You have to be in a bad mood to increase skepticism. And that goes back to, again, rubber duck debugging. The same thing. You're describing what's going on, and as you're describing what's going on, multiple senses are involved. You hear your voice, and then different parts of your brain are helping you to make different decisions. Everybody's familiar with wisdom of the crowds. The interesting part is that sleep on it, it comes from where crowds from within, what it means is that as you're talking to yourself, it's actually the same experience as wisdom of the crowd. So there is nothing wrong with talking with your inner voice, which allows you to basically provide get the same feedback as you would get from wisdom of the crowds. And of course, go through the mental checklist, because mental checklists often help with tunnel vision, like what am I doing, why, and so on. Let's look at another case study, SRE on-call alarm. It's 3 a.m., page alarm just went off. It's AWS queue, SQS queue, customer addresses. John, an SRE on call, woke up. He's unhappy, obviously, it's 3 a.m. What do you think is he supposed to do? Of course, I don't give you enough information yet, but let me give you a little bit more information. So last night, alarm went off at 2 a.m. for another SQS queue, customer orders. And John, who was also on call at the time, he has scaled up number of workers, and that has resolved the issue. Now, given that information, what steps do you think he's supposed to take? And that brings up another psychological term called heuristics. So heuristics are commonly defined as cognitive shortcuts where we try to simplify decisions, especially in the conditions of uncertainty. That comes from our ancestors, let's say, I don't know, 10,000 years ago. If you think it's a lion in front of you, you better run. And if it's not a lion and a squirrel, it doesn't matter. If you run, you survive. Those who didn't run, they just didn't survive. That's why our brain is wired to replace a more complicated problem with a simpler problem, that simpler problem should have a match to a previous experience. And of course, if you look at the picture on the left, you'll see that whale, submarine, or ship, we don't know. I mean, we know it's a cloud. But at the same time, our brain is wired to find certain patterns. And as many of you went to get your degrees in computer science, you probably took design patterns classes. Design patterns are great, except that you have to match to the right pattern. And there is no guarantee that during your development, you're actually doing that correctly. So how can we avoid patterns misuse? Try to understand the problem, right? Do you fully understand it? Then proceed. If not, go back to try to understand it. Is this really the same problem that you've seen before? Only then apply action. Otherwise, go back to trying to understand the problem. Kyler from Fetch, he did a very good talk about that yesterday. It's very similar framework that he was describing. But I want to concentrate on another point here. So why humans need a financial advisor? You've probably seen that Vanguard study. It shows that advisor adds about 3% of advisor alpha annually to its clients. But the reason why it's actually doing that, the majority of the value comes is during periods of greed and fear, when the only thing that advisor is doing actually telling clients don't do anything. Because emotions is what driving people and forcing them to make incorrect decisions. So reality versus correct action. Reality, in this case, John did scale up number of workers. And scaling up number of workers actually did put more pressure on the database. And putting more pressure on database has slowed down processing more important customer requests. So correct action for this use case was to do nothing, since it was a low priority queue where processing would eventually catch up at the low traffic time. Now I want to go back to another great SRE talk that Brandon from Shipped had yesterday. He was talking about that only actionable alarm needs to be there, and noisy alarms should be removed. But from that perspective, how would a backend engineer who edited an alarm would know, will this alarm be actionable or noisy in advance? This alarm was added by a backend engineer in the middle of the day when he was happy adding the alarm, thinking, okay, this alarm would only be triggered if my service is down, or if my service is not processing the queue, which means it does not have security permissions to access the queue. So yes, from a backend engineer perspective, that alarm was completely necessary. But that backend engineer could not see the future, basically, could not think of unknowns that SRE engineer would run into again and try to solve that problem in the middle of the night. That's where all of those great SRE tools that companies have don't really work that well when SRE engineers wake up in the middle of the night and try to make those not often correct decisions. And if you would read incident reports from major corporations, you would see that sometimes in the first minutes of the incidents, SRE engineers actually making not the right calls, making incidents far worse than if they wouldn't do anything. So going back to this example, traffic has increased, which was unexpected, and that caused increased number of messages. SRE engineer made the wrong call. But what we did after the incident, we changed alarm priority, make it lower priority, and allow higher number of messages, updated the runbook. Again, we still don't know. For this particular alarm, we know it's not an issue anymore. But what would happen if issue will come up for a similar SQ, which we haven't thought about in advance? So in general, our rule of thumb is to simplify alarms, to simplify runbooks. Unfortunately, it's not always possible to do because we can't see the future. And that's why, again, I want to, the point that I want to make with that slide is that we need to train SRE engineers to be aware of their biases and try to rethink what they're doing during the incident. So let's look at another case study. That's a little bit different problem. DevOps infrastructure project. If there are DevOps engineers in the room, they all know that they all want to hide underneath functionality of AWS or Google Cloud or whatever and build their own middle layer because it's going to be the best. It's going to make life easier for engineers to use their tools rather than standard tools that are provided by AWS or Google Cloud or Azure. That comes from optimistic bias. So what's optimistic bias? It's a cognitive bias that causes someone to believe that they themselves are less likely to experience a negative event. Or like Mike Tyson said, everybody has a plan until they get punched in the mouth. So it mostly comes from underestimating complexity of the task, ignoring some use cases, making certain tasks impossible to do, and so on. It also puts a burden on a team to maintain that layer, for example, because once you implement those tools on top of AWS, for example, once AWS made a change, you need to continuously maintain that middle layer and bring that functionality into your middle layer, basically just to be on par with AWS or Google Cloud. Another thing which comes into play here is called slow subversion or endowment effect. I'm sure you all heard about that. I'm not going to talk about a lot, but basically, you probably all know that pain from losing $100 in the stock market is much higher than from getting the same from getting $200. And once you own something, then your value is much higher than another person. And there are many examples of that in technology. You always see that people don't want to remove old code, people don't want to remove comments, they'll just comment and then just keep that code there forever, which is, of course, is bad for the code-based maintenance. So example scenario, the start development process. We make cool demo. It's always easy to make a cool demo. You got excited. That's your optimistic bias state. But what's happened after that is then you run into complex and custom cases, and that increases your maintenance costs. Your costs gone up, right? Sometimes you can, and sometimes cannot. You realize that, well, I cannot maintain my solution anymore. But at this point, you're going to move into low subversion state. Because if you just spend, I don't know, 6 months of creating a new solution, you're not going to go to your manager or CTO or whatever and say, hey, my solution sucks, I'm going to try something else. Like, no way, you're living with the solution forever now. And so we are in low subversion state. We're going to stuck to this solution until new employees are going to get hired, old employees are going to leave, and then we're going to start the development cycle again. So unfortunately, that's sometimes a reality, and that's basically we just need to be aware and need to learn how to avoid such cases, so that we don't stuck on an optimal solution forever. Question, how can we unbias these issues? So first of all, start small. That's what Agile is about. At the same time, people are abusing Agile terminology a little bit, and you start small instead of Agile. And basically, that's will allow to limit the impact. Definitely don't start with a company-wide initiative. Pick something small, try it out, see if it's going to work, and continuously iterate. Again, it's one of the features of Agile where you're supposed to start small and continuously iterate. And then after you have a proof of concept, then only you pick a complex problem or service and apply that approach. Again, over a reasonable amount of time. Again, learn and adjust. And don't be afraid to cut your losses if solution is not working. That's very, very tough. If you invested into solving a problem, sometimes it's much easier to go and continue towards that path versus saying, hey, no, I was wrong. It's very, very hard for any engineer to say, hey, I was wrong before. I need to try something else. What's good for engineering? Sometimes optimistic bias can be unbiased by engineering solution. And the engineers will like engineering solution. That would be load testing, chaos engineering. There are so many tools in our disposal that we can use to unbias ourselves. And loss aversion can be unbiased via honest discussions with the team and third parties that are not invested in the solution. So I give you so many examples of what's wrong with biases. Now the question is, can biases work for me? Obviously not all biases are wrong. So first example, if developer has just spent 16 hours increasing unit test coverage, would they really approve new pull request which would decrease coverage? And that's where you're actually using loss aversion to guard against decreased coverage. I actually seen it on PRs firsthand, where a developer would just say, hey, no, I'm going to decline this PR because last week, yes, I did spend so much time. My coverage is now 85%. I'm going to decline this PR until you're going to put coverage back to 85%. So again, you're using loss aversion to help your team to build a better quality software. Another example of, let's say, is anchoring. Company requires 5 nines uptime. It's anchoring. Even if you're not going to get to those 5 nines, you're still going to anchor your engineers to think about what are they supposed to do in order to get to the 5 nines. Even if at the end you're going to get 4 nines instead of 9 or 5, it's still exposure to that number provides us a reference point to build upon. Examples and templates. Herd behavior. Engineers love to copy and paste. Stack Overflow, it was sold for like $1 billion or whatever, because people are actually copying and pasting. And by providing examples and templates, if they're assuming that's what you want your engineers to do, it allows you to rely on herd behavior without actually forcing people to do anything. They'll just follow others, follow the crowd, and they'll copy and paste. Now let's look at the last case study in my presentation. Let's say you have your management wants to build, wants to render 3D scenes with Maya 3D tool. And your company has an urgent need to render that using AWS because that's the cloud that you have access to. So you're looking to select infrastructure to solve that problem. Assuming you don't have any prior experience, no bias, your manager just comes to, hey, that's what we want to do. How would you select between EC2, Spot EC2, the GPU, Lambda, and all the 17 other options that are there? So how would you do that? Option number one, you have attended a great presentation at DevOps Birmingham. And there was a great talk yesterday by JR about how Lambda actually is the right choice for 3D rendering with Blender. Obviously, 3D rendering with Blender is the same thing as 3D rendering with Maya. So how would you think that affects your judgment? And how would you think the judgment would be affected if you attended a presentation about 3D rendering with EC2 with GPU instead of Lambda? And what if by chance you would have missed DevOps Birmingham conference? So that brings up another point. What you see here is examples from a very good book by Daniel Kahneman called Noise. On left top corner is, shooter is accurate. Okay, it's perfect, it's all there. Left bottom is biased. But biases are things that we can at least understand. For example, I know that I have loss aversion bias, but I'm biased in a certain way, and I'm very consistent in that bias. But what also happens on the top right is noise. And noise are things that are unpredictable and can be very, very hard to account for. And of course, when you combine bias and noise, that's what you'll get a picture on bottom right, which is biased and noisy. So going back to example of 3D rendering with Maya, that's what's called occasional noise. It happens when some unpredictable event, like you're attending a DevOps conference, and it affects your judgment. Sometimes in a positive way, sometimes in a negative way. But the whole point, it's noisy, it's unpredictable. And stable pattern noise is arising from factors that are more permanent. For example, many people, I'm not going to ask to raise hands, but ask for yourself, how many people actually trust first page of Google response or first page of Stack Overflow response? But that's Google algorithm. That has nothing to do with the problem that you're trying to solve. Google has no idea what you're doing. At the same time, you would type in Maya with 3D rendering, and you're going to trust that Google will tell you, hey, you're supposed to use AWS Lambda on first page. Second page might tell you to use EC2. But at the same time, we all know, I mean, as engineers, we do know that Google is making billions by selling ads, and even first page links, we don't know. I don't know what they do with algorithms. There is a chance that they're making money out of the first page as well. I'm not going to make any assumptions or predictions about that. Yet we trust Google to deliver us the best results to answer that question. Which again, it brings noise into your solution process. So my final conclusion is knowing the answer. Like I said, I'm not going to tell you how to solve all those problems. You just need to be aware about biases and noises that happen. Try to constantly look at the big picture. What problem am I trying to solve? Why? Will it scale? What's the rollout? And so on. And don't forget that your goal is not to write code. Your goal is to deliver value to the customer. And would you make the same decision after a short break versus the decision that you're making right now? And if you have, do we have questions for Q&A?
Does anyone have questions? Questions? No. I love the shade you threw at Google, by the way. That was excellent. Can we have a round of applause for Vadim? Thank you so much.